All right, welcome to the second part of section 6.3. This is where we're going to finish up section 6.3 at. Back to the what you will you learn. We're going to learn to use inverse properties of logs and exponential functions. So we'll learn about what that is, and then at the very end we'll learn how to graph log functions, which once again we're just going to use an input table, and it should be fairly straightforward. All right, so going back to the definition of a log. So remember that the definition says when you're in log form, you take the base of the log, you raise it to what's after the equal sign, so b to the x, and it's equal to the number or the letter next to the log, which for this one is y. And remember, this goes back and forth. You can go back and forth from one to the other. You can put exponentials back in the log and log back in exponentials. Okay, so we have this idea of what is an inverse. Okay. This says log functions and exponential functions are inverses of each other, which means in layman's term or easier terms, they undo each other. Okay, so we're going to learn more about this, but this right here means when we combine two functions together, f of g of x and g of f of x, that means when we combine them together. So notice we have the log and the exponential together, we have the exponential and the log together. So we notice that when we combine them both, they're both equal to x. And when they're both equal to x, that means that they are inverses to each other. Okay? So, anytime you have a log and the base and the number next to it are the same, they cancel out. And anytime when you have an exponent, a power with an exponent with the same base, so the base of both, they cancel out. Okay, so this is very simple. It's a very strange kind of thing, but they're inverses, so they undo each other, so we can cancel them out. So where does this come into play? Okay, so example 1, it says simplify the following log expressions. All right, so let's look at this first one. And now let's look at the log. So remember, if there's no base, we assume it's a base 10. This is the common log that we learned in the last section. So when we have a base and a log with the same exponent, they cancel, and whatever is left over is our answer. So the answer to this one is 4. Okay. So same thing here. We have a log with a base of 3 with a 3 right next to it. So the log base 3 and the 3 cancel. I'm left with 4x. And it is that easy. It seems strange, but it is that easy. Okay. And then the last one's a little bit harder. It says simplify, however, that the 5 and the 25 are not the same. So we can't just cancel them. So I need to rewrite this so they do cancel. So I have 5, the base of 5. And I recognize that 25 can be written using a base of 5. So would you agree that 25 is 5 squared? And if you do, you can use that information in order to cancel now. Okay? So I have log base 5. Power to a power says I multiply my exponents. So I have 5 to the 2x. Oops. All right, so what's left over now? So what cancels? All right, so let's see here. So the log base 5 of 5 cancels, and I'm left with my answer of 2x. Okay, oops, these problems do not belong here, so we can get these out. Those were actually from the last section. All right, so that's example 1. All right, moving on to example 2. Okay, it says find the inverse equations of the logs. Okay, so this is something that you've probably never done, so we're gonna write some steps out over here, and then we will do the problem on the left. So the first step is to switch x. Oops. Let me erase that. I don't know why I did that. All right. So the first step is to switch x and y. Okay. So we're gonna switch x and y up. Okay. So where the y is, I'm gonna put x. So x equals log base 3 of y plus 3. I don't know what my pen is acting up for today. Alright, so that's step 1. I don't think that is very hard. Alright, step 2. Apply. My pen is strange today. Oh, I apologize for that. So apply log definition. I'm really sorry. I do not know why my pen is not writing very well today. Apply log definition. Okay, so we're going to apply the definition. So back over here. change my color. So remember, you take your base, you raise it to what's after the equal sign, so 3 to the x equals what's next to the log, which is y plus 3. And this is getting annoying. All right, and then lastly, the last step, step 3, is to solve for y. Solve for y. So over here, let me change my pen again. We want to get this y by itself, so I'm going to subtract 3 from both sides, just like I would in Algebra 1. So 3 go away, I'm left with y equals 3 raised to the x minus 3. And there is our inverse equation. Okay, so that is how you find an inverse. And the steps are the same. Every time it says find an inverse, you follow these 3 steps. So let's do one more example just to make sure that we have this correct. Okay, so coming back over here, step 1 was to switch x and y. So from the last page, switch x and y. So x equals ln of 3y plus 2. All right, next step, apply the definition. Now, ln means log base e, so don't forget that. So really there's an e down here. So e raised to the x equals what's next to log, which is 3y plus 2, and it's not working very well. Okay, so that's step 2. And then the last step is to solve for y. So the first step I'm going to do is I'm going to subtract 2 from both sides. 2's cancel. I'm left with 3y equals e to the x minus 2. And then lastly, I'm going to divide by 3. Divide by 3. And 3's cancel, so I'm left with, for my inverse equation, e to the x minus 2 all over 3. And there is my final answer for my inverse. That's a little bit harder, but I think the steps are pretty easy. Once you switch the x and y, you apply the definition of a log, and then you solve for y. And there you go. There you have it. All right, so last but not least, the last part of section 6.3 is called graphing log functions. Okay, and this is what this parent graphs mean. Is this is what the base log graphs look like. Okay, so we're talking about log graphs, meaning log, the equation being y. That's definitely not going to work. Log y equals log base b of x. Okay, so when we have b is greater than 1, okay, b is greater than 1, our graphs look like this. And notice that they both go through the points 1, 0 and 0, 1. Okay, so they look like this. And vice versa on the side. Okay, so there's the parent graphs when b is greater than 1. And then the other graphs would look like when b is less than 1 but bigger than 0. So when these are fractions. And I have really no idea why it is so sloppy today. Something must be going wrong with the computer. So when b are fractions, let's try to get this going right. Doesn't want to do straight lines very good. All right, so when this base is a fraction, this is what the graphs will look like. Okay, so notice they still go through the point 0, 1, and 1, 0, but they are just kind of reversed a little bit. Okay, and now notice I've put in this line. This line right here is the line y equals x, and this is the line y equals x. Okay, and inverses are always reflections of each other, and you can notice that this green line, if I flip it over that y equals x, it lines up, and these two purple lines also, if I flip them over, they're mirror images of each other over this dotted line here, and that's always the case with inverses. Okay, so now, last but not least on this page, it says logs and exponential functions are inverses of each other. Therefore, their ordered pairs just flip-flop. Okay, This one right here on the left, this has an ordered pair of 1, 0, and its inverse has the ordered pair of 0, 1. Okay, so inverses always have flip-flop ordered pairs. Okay, they just flip-flop the x and the y. All right, so last but not least, we're going to graph one log function, and then we're pretty much done. Okay, so step one is when you're graphing logs, we are going to find the inverse. We're going to find the inverse, we're going to graph that, and that will help us to graph our log. Okay, so the inverse, switch x and y. So x equals log base 3 of y. Okay, apply the definition. The base raised to what's after the equal sign is equal to the y value. Okay, so now this is the equation. This is the equation that we're going to use in order to graph our plot. All right, so we're going to plug in -2 first. We're going to plug in -2 first. So 3 to the -2, that's equal to 1 over 3 squared, which is equal to 1/9. So 1/9. Now we're going to do -1. So 3 to the -1 is equal to 1 over 3 to the first, which is just 1/3. And I don't know why that straight lines aren't working very well, so we have 1/3. Anything raised to 0 is equal to 1. That's pretty standard. Now we're going to do 1. What's 3 to the first power? 3 to the first is just 3. And then what's 3 squared? 3 squared is 9. Okay, now what we've come up with a table for is its inverse. We don't want the inverse. We want to graph the log. Okay, we want to graph the log. What we found the table for was its inverse. So if I go back to the last page at the very bottom, the x and the y switch. Okay, so we don't want to graph this table like this. We want to switch the two columns. So now this will be our x and this will be our y. Okay, so that might seem a little weird, but that's what we're going to do. Okay, so our real order pair is x equals 1/9, y equals -2. So x equals 1/9, y equals -2. So it's really close there. X equals 1/3, y equals -1. So 1/3, -1, which is probably like right here. 0, 1, 0, 1. Okay, or sorry, 1, 0. 3, 1, so 3 the first one up, and 9, 2, so 9 is 1 over here, and go right, it's about right here. I know that's not on there, but so here is our logarithm shape. Let's see if I can draw this, and there we go, and it extends in both directions. Okay, so first you find the inverse, make the table for the inverse because it's easier to do an exponential function than it is a log. And then you flip-flop the points in order to graph the log. If we would have done -2 1/9, -1 1/3, we would have graphed the 3 to the x, but that's not what we want to graph. We want to graph the original logs. We have to switch them. Okay, so that wraps up section 6.3. Hopefully that makes some sense. I'll answer any questions tomorrow, and we'll do some practice. See you tomorrow.